It didn't take a rocket scientist to figure out that it looks like photons from light are responsible for growing the EZ. Whenever we have a hydrophilic material sitting next to water, there will always be some EZ water because the energy is around to create EZ water. You got a red blood cell, it's 6 or 7 micrometers in diameter, but the capillaries are 3 or 4 micrometers in diameter.
Back
got a
pressure.
problem.
Yeah, why aren't they getting stuck?
Without enough EZ water in your cells will be operating in a dysfunctional way, or maybe a pathological way even. What can you do to build EZ water in your cells? You put one electrode in the negative and one electrode in the positive, and in theory, you ought to be able to light a light bulb from it. Well, we've done the experiment.
Will EZ water be able to power your grow lights one day? Well, in this video, we're going to get into it. You're here with Mark Boutwell and Jared Pollack on Perfect Gardens TV. Please remember to like, share, and subscribe. And if you haven't checked us out on Instagram and Facebook, make sure to do so. We also have our $2.99 membership where there's over 115 growers ready and willing to assist you through your growing practices. Let's go ahead and get into the video, guys. Make sure to hit the join button on the bottom of every video.
Okay, so one point is that these healthy looking people are filled with EZ water. Every cell in the body is filled with EZ water. And for the reasons that I showed you earlier, that the solids inside the cell are hydrophilic, and so EZ water builds from the surfaces, and they're so crowded, essentially all of this water is the water that fills the cell. And so these people are filled with EZ water. And I'm going to be later talking about what happens if you have a deficiency of EZ water. You might not look as healthy as these people look. Okay, so the original question, many slides back, is EZ water physically distinct from liquid water? And the answer is yes. I gave you the list, but I didn't go over so much of the list. And the best that we understand is it's a layered honeycomb structure. We think that's right, but you know, as it's been said for many years, even the most beautiful theories can be destroyed by one ugly fact. So we think it's right, but you know, who can be sure? And it has information storage capability, of which I've shown you only a small bit of an increasingly voluminous evidence. Okay, so it's a battery, right? Remember the slide showing the negative next to the positive? That's a battery. And batteries need charge. So your smartphone battery or your smartphone won't work if you didn't plug it in overnight. And just the same, every battery needs to be charged or recharged. And so where does the energy come from? You can't take one of these chambers and plug it into the receptacle. I mean, unless someone can sort of imagine how that can be done. I actually take that back. I think you can. Well, anyway, we didn't really think about that, and we couldn't figure it out. We really couldn't. Maybe that's because of the stupidity of the guy who runs the lab, or the lack of creativity, or I don't know what, but we couldn't figure it out. And finally, one student figured it out. He did it he figured out it was light that was responsible for charging the battery. I'll explain that in a moment. But so what he did was he's at the lab a bench. He's got one of these little chambers that I showed you in one of the early slides. And he noticed that right next to him on the lab bench was a gooseneck lamp, you know, one with that bends over. And so he bent it over and he shined light on the chamber, and what he noticed looked like this. So,
wow.
Yeah, wow is right. When I this is real data. This is not. When I saw it, I was flabbergasted. I couldn't believe. So here's Naphion, the material that we use quite often, which builds an EZ, and you can see the EZ here and the microsphere is here. And normally the boundary between the EZ and the microspheres is straight. It's parallel to here. EZ is building, building, building. But where he shined the light, the EZ grew like crazy. I mean, really powerful effect. So I said to him, why don't you remove the light and see what happens? So he removed the light, and it went back. It took tens of minutes, but it went back to the boundary being straight. So it didn't take a rocket scientist to figure out that it looks like photons from light are responsible for growing the EZ. And that was a real revelation for us, because, light, that's interesting. So we went ahead and we did experiments, serious experiments, to find out, well, which wavelength of light is responsible. And we studied wavelengths that we could access, starting at the short wavelength and using ultraviolet light, increasing the wavelength to the visible violet, and all through the spectrum to the red at the other end, at the long end, and then to infrared beyond that. And what we found is that the most effective by far is infrared. Infrared almost 1,000 times more effective than light in the visible spectrum. So a lot of people don't know about infrared. What's infrared exactly? So if you go to your electric range and you see, if you've got coils, you see the coils glowing, you turn it on and you say, heat is coming from that orange glow, and therefore there must be infrared energy that's coming from it. And that's correct. Infrared and heat are not exactly the same, but close. I don't want to go into the differences. It's sort of technical issue. But anyway, that's most people's perception of where infrared comes from. But in fact, infrared is coming from everywhere. So if I were to, for example, if you were to turn off the lights and darken your respective rooms, and I were to come with an infrared camera, that is a camera whose sensor doesn't pick up visible light, but picks up infrared light, I would get a beautiful image, an image that might look like this. So even if you can't see with your eyes, that your eyes are not detecting any light at all, the camera that's sensitive to these long infrared wavelengths will create images, and that's why the military uses it at nighttime.
It's funny too, not to dive too much into this, but when people are on heavy psychedelics like ayahuasca, this is what they see too when they look at different images or different like rocks or certain things. They'll see auras around certain images. So and I'm realizing is when our eyes are at these hypersensitivity moments of these medicines, are we seeing more of the infrared light possibly?
That may well be. I haven't tried ayahuasca myself, although it's interesting I think to try. But I hadn't heard before. I know quite a few people who have experienced it, and they haven't told me about what you're telling me. So it's really interesting. So what we see is a function of the limits of our eyes. And typically the limits are in what we call the visible range, but that's sort of an artificial cutoff. Right. There are some species that do see in the infrared. And so I could imagine that the effects of ayahuasca could impact our visual system so that we may see a wider range of wavelengths. Absolutely. Yeah.
Wow. Really interesting.
Yeah.
Really interesting.
Yeah, and love your comments. This is available. These wavelengths are all around us. By the way, they're also coming from inside because, we're metabolizing, and the metabolism is generating heat, which is essentially the same as infrared. So we have infrared coming from inside, from our core, and also from outside. So when we think of our body, we're just simply bombarded by infrared light. And so because there's infrared all over, not just for us, but also outside of us, which means that whenever we have a hydrophilic material sitting next to water, there will always be some EZ water because the energy is around to create EZ water. And if we are to add a more infrared light, then what happens is grows the EZ. This is supposed to grow slowly, but okay. And if we remove it, then the EZ will go down to its default amount. So it's very sensitive to the amount of EZ water. Now, so the question was, well, what's the energy for buildup? And what I've shown you is that the EZ buildup is powered by light, photonic energy, which orders the water and charges the water battery. So, the ordering, we don't ordinarily think about order and energy and light, but you can't go from disorder, which would typify liquid water, to order, which typifies EZ water. You can't do it without energy. This is a fundamental law of nature, and you can understand, for example, your respective desks, offices, they get progressively messy, right? And that's easy. It's like rolling off a log. But one day you come in and say, I can't deal with this. In order to, in order to get it in order again, you have to expend some energy, right? Put this pile here and that pile there. And so the principle applies all over. It's not just restricted to ordering your office. Whenever you create order, like EZ water, you got to put in energy. So anyway, this light energy, what it does is it orders the water from liquid water to EZ water, and it basically charges the water battery. That is, it separates the charge.
This really blows my mind, because what you know about, have you ever heard about mobile nutrients and immobile nutrients?
No.
Okay, so some, like calcium, is an immobile nutrient. Once when the plant's growing, it needs to be placed in a certain spot. But once it's there, it doesn't move anymore. But then other things like nitrogen or phosphorus or things like that, they're mobile nutrients. So once they're placed, the plant can rob them from certain leaves to take them to other places. And what I'm thinking about this is when you're talking, it's like the negative ionic charges, like certain minerals, if they don't have a negative ionic charge, or if, like we're using like fertilizers like urea, and there's positives and negatives or whatever, that probably affects the EZ charge. And if they don't get placed in the plant at the time that the plant needs them, or as they're using them, then as the light and the photons come down, the order of those molecules aren't being ordered properly. And it could be a reason why plants run into nutrient deficiencies and toxicities, and bugs come and get attracted to them, is because that order is throwing off an off vibration, if that makes sense. I don't know if that makes sense, but that's what I see in my mind.
Well, yeah. I can't comment. I got to give that some thought. I wasn't aware of this concept, but yeah, I can imagine so. All right, so I'm going to progress, and so I mean, basically it's light. So light that creates all these goodies that you get from it, essentially energy, potential energy. Order is potential energy, and charges separated are potential energy. So in essence, it means that just lying in the sun can create this kind of energy. And as you know, the sun, it produces both light and heat. And measurements have shown that at least half of the energy coming from the sun is infrared energy. So the infrared energy can basically build charge this way. And so if that's true, then you kind of expect that if that you ought to be able to harvest this kind of energy, because if the energy is building just by exposure from light, you ought to be able to do it. But my guess is that neither one of you have ever seen a glass of water like this doing work. Am I right or wrong?
Well, no, like maybe water turbines or something, but
yeah, but I mean, just this, basically, essentially, not just essentially that. So I'm going to give you an example of a glass of water or a little body of water doing work, which means you actually can harvest it. And as this is done by another undergraduate student who, again, was doing what he was not supposed to do. They do that. The younger they are, the more, I don't know, rebellious, open-minded, curious. So this student, we just found out that Nafion, the material that we like to use a lot, that it comes not only in sheets, which we had used, but also comes in tubes, like a straw. And so I asked the student to go into the lab and see whether we could get exclusion zones building next to this surface. And we didn't know for sure because the surface is curved and sheets of Nafion are flat. And so he was supposed to go in and find out, is there an exclusion zone that builds in this direction and also inside in this direction? So he went in, and it took only one week for him to find out that, yes, there are perfectly fine exclusion zones that build next to the curved surfaces, just as they do flat surfaces. And then, because I was busy with stuff, I didn't have a chance to discuss with him what would be the next step. But he decided himself, because he was curious and industrious, to go to the next step himself. And one day I was sitting in my office and I had a visitor and we were chatting about something. I think he was an important visitor, but maybe not as interesting as other visitors. And the student comes in, and I actually sort of welcomed him because maybe the discussion, as I recall, was not so interesting. And usually what the students do is they kind of gingerly knock at the door, even though the door was ajar. Slightly ajar. They're sort of, they tend to be polite. They look and, do you have a moment or something? But this guy came barging in, pushing the door open, and he said, I found something interesting I got to share with you. Okay, share with me. Partly happy to break up the conversation that was occurring, and also slightly skeptical. What could he be presenting that would be so interesting, earth-shattering? So he told me, he said, I'm doing the experiment, and I've got a microscope sitting down here, microscope lens looking at this, and I've got particles, microspheres in the water, and I look through the lens and I see that what's going on is that, well, I'm sorry, is that the water is flowing through the tube, like through a straw, and it never stops. And wow, I said, if you're right, I'm thinking, if you're right, and it turned out he was right, we went and checked. This is amazing because usually,
this is free energy.
Where does the energy come from? You got it right. Where does the energy? And I'm thinking, we know where the energy is coming from because we've just determined that the infrared energy is being absorbed by the water. You see, so
wow.
So we had the idea. Wow is right.
So you're saying just putting glass tubes in water in the easy setting with light hitting it, it creates a turbine experience that we could pull electricity off of?
Nafion, not glass.
Well, I'm not suggesting electricity, but that is possible. I'm suggesting work is done, and I'll show you in a moment some additional experiments. But somehow the energy is being converted into mechanical energy. This is mechanical energy that's needed to drive this. So we know the infrared is coming in, being absorbed by the water and creating EZ. So we presume, I'll show you an experiment in a moment, presume that EZ is growing here and here, but most interesting is here. And somehow, I'll show you in a moment, this is leading to a driving force, which is driving the water through here. So let me show you.
Wow.
Yeah, hold your enthusiasm is fantastic. This is the experiment, how it's done. So you fill the inside of the tube with water, make sure there are no air bubbles, and then you immerse it into a bath of water and microspheres. You take it over to the microscope, minimize the light, look in the microscope, and here's what you find. So here's a Naphion and the exclusion zone just inside the tube. And this is going, we've had this going for a day and a half without stopping.
Wow.
We know how to make it go even beyond a day and a half. But we have critical colleagues, and someone came and saw the experiment and said, well, there must be something weird about Naphion. Why don't you use another tube, some other material, other hydrophilic material that has exclusion zones, and see if you find the same thing. And if you can, then we'll begin to believe it. Well, we couldn't find the right tubes, right size, so we essentially created them ourselves. And what we did, we took a gel, like Jello, but not gel, little chunk. And as it was gelling, when it was still in the liquid state, we put a wire in, and then it gelled, and we pulled the wire out, so we got a chunk of gel with a tunnel right in the middle. So we take this chunk with tunnel, and we immerse it in water and microspheres, a suspension of microspheres, and we look to see what's going on. And so this is what it looks like. So this is a polyacrylic acid gel. Here's gel, and the tunnel goes from here to here. And what you see here is a still of what happens after 5 or 10 minutes. You see the EZ grows from here, and the EZ grows from here, and all the microspheres are pushed to the center like this. And what happens is this, you got flow.
Wow.
We've demonstrated this now in more than a half dozen different gels. Same result. Speed differs, other characteristics differ, but essentially any gel that you take shows pretty much the same result. So someone said—
You solved our electricity problem.
Well, there's another way of solving it that I think is simpler than this. I'll get to that toward the end. But yeah, I mean, anytime you've got separated negative and positive charges that are separated with the energy of light, which is free, you can get free electricity.
Wow. So
yeah, but we'll get to that. Okay, so someone said, well, you actually think this is run by light energy. There's a simple way to find out, which we hadn't thought of, and that is just crank up the microscope light and see what happens. And so we did that, and we found and published this, that we, just by cranking up the microscope light, we could get a 5 times increase of speed. So it really is run by light. And so what we deduced as the mechanism looks something like this. So this is one of these Naphion tubes that are put in, should be microscope suspension. It's not a solution, but we put it in, and you can see the EZ, the microsphere region here, and also outside. And with the EZ here, so we know that the EZ is negatively charged, and there should be positive charges here. So we have a situation that looks like this. Here's a Naphion tube. You've got the EZ here with negative charges, and the bulk water sitting, or liquid water, sitting with positive charges. And we've confirmed this and this. And these positive charges, the negative charges are stuck to the Naphion, but the positive charges are mostly free, and they want to get as far away as they can from one another, right?
That's so like cation exchanges sites. You know, like the positive charge, tell me if I'm wrong, is like calcium, magnesium, sodium is a positive, and they their purpose is they attach the negative ionic minerals and carry them right through as a plant is doing certain things throughout different like veg or flowering or blooming or whatever, and it attaches them. And the calcium and it's so interesting because I see all the negatives as negative ionic minerals, and I see the positives as the cations that are carrying the minerals and like pulling them as they need them in different places.
Well, that's interesting. Yeah, it could be closely related to the kind of mechanism that we see here, because in this case, yeah, it's the free positive charges that want to get away, so they move out this way or out this way. And as soon as they start moving, then more water is dragged in to replace what has been pushed out, or it flows out, and the charges once again build, and so the process is perpetuated, keeps going, and this could be responsible for moving a whole lot of stuff, including what you discussed a moment ago. Yeah. So this is what we think is the mechanism, and you can actually measure, if you measure the pH of the solution out here, it gets more and more positive, that is more and more acidic as this flow occurs. So we know that these positive charges are being moved out of the center, and it's all propelled by light. So, wow. So we have a situation where work is done, and so to do work, you need energy. And the only energy that we could think of, unless someone could come up with another one, is the energy absorption. We talked about the infrared energy coming and getting absorbed by the water and being transferred. So indeed, water transduces light energy into mechanical energy. So it means that this water is capable, under the right circumstance, is capable of doing work. The water is a transducer.
Wow. So
then the question arises, does human biology use radiant energy? Would you, wouldn't you think about it? So picture yourself as Mother Nature. This is the best image I could get as to what Mother Nature might look like. You may think of some better images, but who knows? And here's the agriculture that comes from Mother Nature. So think of yourself as Mother Nature. Okay, you've been pretty successful. You've dealt with green plants, right? And you've used photosynthesis to supply the energy, and also same thing with some single-cell organisms that came before the green plants, right? Same thing, photosynthesis. So what's step one in photosynthesis? Step one is the absorption of light and the separation of water with the energy of light into plus and minus. It's very similar to what I've been presenting here. Creating the easy layer immediately. Well, I think so, and you're very perceptive, and I think it's possible that the mechanism that we've been talking about here is actually a generic kind of step one of photosynthesis, and that nature has figured out the best implementation of it and use chlorophyll to do the job, and do the job with 100% efficiency in step one. And that first step of photosynthesis may be one example or one manifestation of the more general principle, which I'm trying to elucidate here. So if you're photosynthesis separating the minerals possibly from the cation exchanges? I don't know. I got to tell you, I'm not intimately familiar with all the steps of photosynthesis except for the step one, which is using light to separate water into plus and minus.
This is brilliant stuff, man. This is brilliant stuff here. Well, huge connections, man.
There are connections, but so let me go on with this. The question is, if you're Mother Nature and you've used light photosynthesis very effectively And one day you're saying to yourself, oh, you're yawning. I'm bored. I already did my job. I did a good job with green plants, and before that with single-celled organisms. I think, let me create animals. And okay, so I'm going to create animals, and animals can move around. They can forage. They can get their energy, their sustenance from food, various sorts. But I got this mechanism in my back pocket that I've used pretty successfully. It's called photosynthesis, and it involves light. And what should I do? Should I just discard it, or should I sort of keep it, maybe along with the food as a kind of backup mechanism or supplementary mechanism or something? Well, if you were in Mother Nature's place, I think, or at least I would opt for, don't discard it. Why not keep it? What do I lose by keeping it? And I think it's possible that Mother Nature has actually chosen that. And so what I'm getting to is the possibility that some of our energy comes from light, splitting the water, getting battery-like effects from that. So the first example of this, the first place to look is you or me, and we're absorbing infrared energy all the time. Okay, and some of it doesn't get through very deeply. Other wavelengths do get through. And one idea is about the cardiovascular system, which you mentioned earlier. And the capillaries are actually right near the surface, and so the cardiovascular system is getting input of infrared energy. And of course, that infrared energy builds EZ and separates charge and basically gives you energy. And the first question is it possible that somehow this infrared energy is helping to drive the blood flow in our cardiovascular system? I got to tell you that when I first thought about it, I said, this is preposterous. I can't imagine this, because in my PhD work, I was studying the pressures and flows in the cardiovascular system, and I thought, we have it all worked out. There's no question, no problem. It all fits together very nicely. And the idea that some new kind of energy could be important, it just didn't seem logical or likely. And everything changed on a trip to Russia. So I went to Russia. I'll explain this in a moment. I went to Russia to visit my friend Vladimir Vyakov, who's a professor at Moscow University. And he introduced me, these are red blood cells, by the way, introduced me to his colleague who was talking about this, the cardiovascular system, the red blood cells, and the capillaries. So this is a piece of muscle tissue. Here's a capillary. Here's another capillary. And these are red cells that are running through the capillary. And he was telling me there's a big problem. And of course, I was totally skeptical. What kind of problem? I thought, with my nose cutting the clouds, arrogantly thinking, we got it all worked out. What are you going to tell me that's interesting? Well, within 5 minutes, this guy had me convinced that there was a big problem that we had never, ever thought of. And it's so sort of simple and obvious. You got a red blood cell. It's 6 or 7 micrometers in diameter. But the capillaries are 3 or 4 micrometers in diameter.
Yeah, back
got a
pressure.
problem.
Yeah, why aren't they getting stuck?
Yeah, you got a plumbing problem, right? It's sort of like your toilet,
Yeah.
depending, sometimes you
The turd's too big. You can say it.
You got it. Turd's too big. Yeah, and so you can see it here in the video. So the red blood cells are getting squeezed in order to fit through, and this guy's having a lot of trouble working his way through. So this Russian guy is telling me he made a calculation, and the calculation basically calculations showed that the amount of energy that the system needs to squeeze each red blood cell in order to get through these narrow channels. He calculated that if the heart alone is responsible, that it would need to develop a huge pressure. He calculated the pressure would be something like 1 million times the actual pressure that's developed by the left ventricle.
Jeez.
So, that's what we call high blood pressure.
It makes
So
sense, right? When you say that, it makes complete sense. Like it would wear out way faster.
Oh yeah, it would wear out. But yeah, I mean, that's a long-term problem. But the short-term problem is, where does the energy come from? He said, there's got to be another energy source, because the heart simply can't do it. And he calculated 1 million times the pressure would be needed, even if he's off by 10 times or 100 times or whatever. Still, the difference between what that pressure is in a normal heart and what the pressure would need to be if it were the only source of energy to propel this kind of motion, the big difference between the two. And I think some other investigators have also recognized this is a big problem. And we've recognized it's a big problem as well. So where does the energy come from? Well, this guy had a few ideas. The translation from Russian to English was a little bit difficult, but while he was talking about his ideas, I'm scratching my head and thinking, well, wait a second. We just did an experiment in the lab showing that if you have a tube that looks like one of these capillaries, that the tube itself, because of the EZ inside the tube, could propel the water essentially along. And maybe it's this kind of propulsion that exists in the cardiovascular system to help propel the blood. And so the idea is, remember, in this hollow tube sitting inside the water, it was light, radiant energy that drives the flow. It creates EZ, separates charge, and the charges the flow goes through the tube. And so we thought radiant energy help drive blood flow in your cardiovascular system, and maybe even mine. And so I asked my student if he wanted to study this, and I got to tell you, before you look at the hint, I got to tell you that he was so skeptical, and he told me afterward, only after he completed a series of experiments that yielded a positive result, he said he thought I was nuts for even suggesting this question about blood flow in the cardiovascular system. So anyway, he was a diligent student, and the first thing he did was to look in the literature. And so he found an experiment published now about a decade ago with mice. And these investigators from Israel were studying blood flow in mice. And after their experiment was over, they sacrificed the mouse. And what they found was that the flow didn't stop. It's supposed to stop, the mouse is dead, but the flow is continuing. And so they drew a conclusion. They published that there's got to be some other source of energy that's driving the flow besides the heart. And that was critical for him to find it. They studied it, 10 minutes after the mouse, they sacrificed the mouse, 20 minutes, 30 minutes, 1 hour. And it still flowed, at much lower velocity, but it still flowed. And also,
this is teetering on anti-aging.
Why?
Well, just because I'm imagining the battery system, the breaking down of cells, and why things fell. I feel like just recently I started getting into this conversation around anti-aging and the specific mechanism that causes us to age. And I haven't, just be straight with you, I haven't made the complete connection in my mind, but as you're talking again, I'm pulling information from this conversation I had about what did they call it? It's something specific. But it's something specific that causes us to age. And what you're talking about and that last conversation, there's connections happening right here.
Okay, well, that's great. I think it's not clear why we age, because maybe there are some theories, but if you take, for example, some insects, there are some insects that live for only one day. There are some trees like baobab trees that live for 5,000 years. Why is this? And we live for, I don't know, 100 years or 90 years, plus or minus 10, 15 years. Why is that? And I think this is an issue that needs consideration. And I think only after we figure out what is it exactly that is responsible for aging, and for this distinction, this vast distinction on the amount of longevity, then we're prepared to maybe go the next step. And that's my opinion on it. Maybe differs from your opinion and the opinion of others, but yeah, it's a good question. So maybe this does deal with that, but you know, if blood keeps flowing after you're dead, so to speak, at least for a period of time, you even have to raise the question of how do we define death? Because you know, you've got some flow that's occurring. It turns out my student was diligent and he looked in the literature and he found a half dozen studies over the past 100 years that actually found the same result, that in different species and different kinds of experiments, altogether different experiments, that even after you die or an animal dies or the subject dies, flow continues. So there's got to be something going on. And that's what gave him, my student, Zheng Li, some incentive to pursue our own experiments. And so, so what he did, I'll summarize here, it's now submitted for publication. He used the chick embryo. And the chick embryo, the embryo is growing, and at 3 days' time, it's a pretty pure system. You can see the cardiovascular system, but the neurological control system is not very well developed yet, nor is the hormonal system well developed yet. So it's fairly pure. So if you lop off the one end of the egg, a shell, you can see the cardiovascular system here growing in the heart and various vessels and such. And he developed an optical system in which he could look at a vessel here and a vessel here, and to check to see what's going on. So the first thing he did was to stop the heart. And you can do this very easily by injecting potassium chloride. It stops within a few seconds. And so his result looks something like this. So on this axis is a blood flow velocity. On this axis is time. So the first thing is he injects the potassium chloride, the heart stops, and the flow goes down, as you might expect. It doesn't go to zero, though. There's still residual flow that's occurring. And then what he does, he takes the signature feature of the mechanism that I showed you in the last few slides. That is, you apply infrared, and infrared should enhance the charge separation, the EZ growth, and therefore the flow. So he applies infrared with a lamp, and you can see that after a short time, the flow increases by a factor of 3 times or so. And then he removes the infrared and it goes back down to the control level. So it means that the signature feature of this flow mechanism that I described in those few slides appears to be operating. And this is the system that is apparently responsible for driving flow. So it means that this mechanism is operating in your heart and my heart, presumably, unless there's a gross difference between the chick heart and our heart. And we don't know yet how much of a role it plays. For technical reasons, it's really difficult to quantify. It could be 5% of the energy is coming from this. It could be 50% of the energy. It could even be 90% of the energy. We don't know the answer, but it's the frontier. So anyway, in your heart and my heart, it's not just the heart that's driving the flow, it's also the vessels. So indeed, radiant energy does help drive blood flow. And similar for plant flow, right? Infrared energy is really important. And so I showed you about the xylem tubes, and so you've got hollow tubes. These are running vertically, and you can imagine that the same sort of flow is being propelled in these xylem tubes that's being propelled in your blood vessels. We can see the exclusion zone here, and we infer from that that you've got negative charge here, positive charge here, and the positive charges wanting to get away from one another are driving and pushing upward in this way. And that kind of explains why the flow depends on the season. Yeah, so, springtime, you've got lots of green here. It's warm, it's getting warm. And so if it's getting warm, it means you've got infrared energy. And the infrared energy is getting absorbed by the tissues inside of the xylem, which runs from down here all the way up here. And the fact that infrared is being absorbed means that the process that I just showed you is energized, and so flow begins, and it keeps everything green. When you get to the fall, it's cold. You lose infrared, water flow stops. You get dehydration in the leaves. They turn beautiful colors and they drop off. They're dead, essentially. So the infrared that I've been talking about has a rather, I think, direct effect on agriculture and what happens during the seasons. So for Mother Nature, I'm suggesting not that that we as humans and photosynthesize, but that we and also the various plants use light as the plants in a more direct way or a more efficient way, and us at least as in the background using light to split water and drive various processes. So now getting toward the end, how does radiant energy facilitate function more generally? And I'm talking about you and me. How does it do it? So we know, starting with green algae, for example, it photosynthesizes. Some bacteria, nice slide, I think, photosynthesize. And of course, green plants. So what happens in green plants? Well, the water that comes from rain gets absorbed by the roots. And as I described to you, comes up you have a question, sorry?
I was just making, I think, your connection with the clouds, with evaporation from the plant.
Oh, okay. Well, yeah. That the evaporation is important in the clouds. So anyway, but yeah, it will get absorbed by the roots and transported up into the leaves. So you got water in the leaves, you got water, and you've got infrared energy coming from the sun. And so what happens is the water, first step in photosynthesis, gets split into the positive and the negative components. So that's what happens in the green plants. And as I suggested to you, something similar happens next to any, or most, I should say, hydrophilic materials. You get this splitting into negative and positive. So this is easy, or fourth phase. And here are protons, basically, or protons connected to water, which is hydronium ion. Probably that's more likely, this separation of charge. So this gives you potential energy, and that potential energy can be released inside your cells, right? Potential energy, important. And a little bit more specifically, the way this works is you've got a cell that's sitting here, and you've got solids inside the cell. Let's say proteins, 70% of all the solids are sitting here, but the others actually act similarly. And because the surfaces tend to be charged, you got easy water that builds with negative charge in it. So inside the cell that's filled with all of these negative charges, they repel one another, all right? Because negative charges, they want to get away from one another. as quickly and as far as possible, right? Negative, negative repel. So you've got that problem, so to speak, inside the cell, but that so-called problem is actually potential energy. You've got all these negatives over here, and that's potential energy, which could be expended as they follow their natural tendency to come apart from one another. And this potential energy, I argue, and I argued in that book that you saw being held by the child, the fourth phase of water, that potential energy is used to drive protein folding. So what's protein folding? Well, protein folding is everything that your cell does is done, all the work is done by protein folding, right? If you, for example, you take a muscle cell, and what happens is the muscle cell, when it wants to contract, what happens is the proteins go from some extended state to some folded state. Protein fold, and that's what is responsible for the muscle's energy for shortening and developing tension. And then at the end of that, it comes back to the initial state. So I argue in the second half of that Cells and Gels book that this is what this energy is being used, this potential energy is used to drive that kind of protein folding. And an example is this. So you've got a protein here, and imagine this is a protein sitting inside of either a muscle cell or a nerve cell or a secretory. It doesn't matter what kind of cell, and it's surrounded by easy water, right? And so what happens is the easy water converts into ordinary water. All those negative charges disperse, and the protein folds. And then after it folds, after, say, the contraction is ended, it returns to its initial state, and the easy water builds up again during that. And the problem is that if you don't have that easy water, or if you don't have enough of it, then it can't do what it's supposed to do.
This makes me want to drink water right now.
Keep drinking, and I will join you. I don't drink enough.
Cheers.
Yeah.
So this is how energy is used by the cell, by the proteins inside of the cell. So in a little bit more detail, so you got potential energy from the EZ, which drives work. But if you go through the details of what I've shown you during the past hour or 2 hours or whatever, remember, light builds EZ. It builds the negative charge that we see here. This gives you energy, and the energy can do work by folding of proteins. So if you draw the connection, light is actually doing work. Light is doing work. We know that happens in plants, but I'm arguing that it happens in you also. And so,
they say the sun gives us what, vitamin like D12, right? So I mean, we're producing something from the sun, right? So that has to be a form of energy.
Right. It makes me want to take the blinds off of my windows because it's affecting my energy workload. Like I'm not pretty much
take the blinds off. Totally, or move to Mexico or Yucatan or something. I know some people who have been chronically ill, move to Mexico, lie in the sun for a year or two, and get healed.
Wow.
Yeah, and in Japan, I heard that cancer patients are put next to windows where there's a lot of sunlight, and particularly for reasons that are a little bit obscure, to the east-facing sun. So the morning sun apparently has some health-giving effects that are apparently realized in the therapeutic effects in patients with cancer. So yeah.
Have you ever heard of sun gazers?
Yes, I have.
And it produces a white film on the top of their mouth that supposedly is enough substance for them to survive.
Didn't know about that, but I'm learning as you're talking. You guys have wonderful funds of knowledge.
Well, I mean, there's YouTube, right? There's YouTube out there that we watch, and you're the scientist. I'm trying to get rid of the conspiracy and know what is legitimate and has been verified. And so I'm trying to make I'm seeing these connections, but they look really legitimate. And so yeah.
Well, I hope so.
Yeah, me too.
Okay, so where do we get our energy then? So I mean, this is something, it's not settled, but obviously we get some energy from food. You do, I do, we all do. But also I think we get energy from light, and light is absorbed by the water. It builds easy and gives us energy, as I've been describing, both in the cardiovascular system and essentially every cell in your body. Now, so should this matter to you? Well, I think to you guys it really does matter, but I think beyond just you guys, it should matter to anybody and everybody, because there are a couple of, you might say, take-home messages or central features that if we keep in mind, I think we can move toward better health than we enjoy right now. And the 2 points of central points are that light matters. It's not irrelevant at all. It's central, and especially infrared, and water matters as well. And that's why I often will keep a glass of this hydrating stuff nearby. And I know that I don't drink enough, but we need this. Okay, so the question that you want to know is what builds easy water in your cells? And I'm just going to go quickly through a half dozen very simple expedients that you can follow to build easy water, and therefore to build health. Because without enough easy water in your cells will be operating in a dysfunctional way, or maybe a pathological way even. So what can you do to build easy water in your cells? Well, the first thing is to do what I just did, drink a lot of water, because water is the raw material for building easy water. So you swallow the water, and the infrared energy that's coming in your body from inside and from outside is acting to build easy water. So some of the water you drink gets turned into easy water, other gets peed out. But it's one way. Keeping hydrated is, I mean, what is hydration? It's basically water inside the cells, and that is easy water. Second one is green juicing, right? So you go into your backyard and you pull up some plants, the leaves of some freshly growing plants in your backyard. You put it into this mashing machine if you want, or do it by hand. And so basically, what are you getting out of that? Well, you're squeezing the juice from the leaves of the plant. And what is that juice? Well, the juice is what's inside the cells. Those are fresh, newly minted green leaves. They're full of easy water, a lot of easy water. So what you're doing is you're getting rid of the solids, which fill you up pretty quickly, but what you're drinking is the important part of the plant, namely the easy water. So you're bypassing the step of converting the ordinary water into easy water. You're actually drinking the easy water. So that's another thing that you can do. A third is, you guys know, but not everybody knows, there are many substances that have been touted as health-giving, health-conferring, dating back 5,000 years or even longer from the Ayurvedic tradition in India. And nobody's known exactly why these are so effective. There's turmeric, there's holy basil, coconut water, ghee, whatever. And we studied these. And our hypothesis was that the reason that, for example, turmeric is so good for so much of what ails you is that not that it's got 29 different mechanisms of action, but that they've got one mechanism of action that whose effect is demonstrated in 29 different regions of your body. And so what could that be? And we thought if turmeric builds easy water, and the easy water goes to all the cells that need it, that's a possibility. So we studied all of these agents. We found that all of them build easy water in concentrations that we would expect inside our body. So we think the reason that all of these are so effective is simply that they build easy water, and you need easy water. And we found, by the way, the most effective one of all is ghee. It surprised us a bit, but ghee builds exclusion zones that are something on the order of up to 1 millimeter.
Are you saying ghee, the refined butter?
Yes, the same is used by
Wow,
people.
isn't that coffee guy dump all kinds of ghee in his coffee?
Dave Asprey.
Yeah,
He does.
Wow,
he's a pretty healthy guy. He wasn't early on, but he had an experience being overweight and ill, going to the Himalayas, and some of the people he met there said, oh, ghee is really important, and they mixed the ghee with the coffee, and he was healed, and he immersed himself now into the field of biohacking, and very successfully. So
wow,
yeah, he's a key person. Okay, we just talked about sunshine. You raised the question, and I mentioned a friend who spent a couple of years in the Yucatan to absorb the sunlight there. And, so here where I live in Seattle, in the wintertime, including right now, if I look out, I see clouds. It's really cloudy here. And on occasion, when the sun peeps his head through, people are happy. Mm-hmm. And the usual interpretation of that is it's a psychological effect, which it may be. You see darkness, and when darkness transitions into light, we're happy about it. And I think that may certainly be true. But there's another possible mechanism, and that is, the sunshine contains infrared. And so the sun comes out, and we're exposed to infrared energy, builds EZ. And the buildup of EZ around our body brings us back from a sad, depressed, whatever state, to a state, the normal state, the default state, which is a state of happiness. So that might.
The most amount of suicides per capita are in Alaska, Anchorage, Alaska, and it normally peaks during the winter months. Mm-hmm.
Yeah, it's pretty dark in Anchorage in the winter months. They get some of the same systems that we get in Seattle, and I certainly could understand it. And more people in some of these northern climes, particularly in Scandinavia, go south, and it's understandable. More sunshine, they feel better. So anyway, this is a possible reason why we feel better in where we experience sunshine. So the best example of that perhaps is in the sauna. We say sauna. The Finns say sauna. The Russians say banya. And I've had the experience myself. So what do we experience in a sauna? Well, it's hot, right? Hot, heat, infrared. The two are virtually the same. So whether it's a dry sauna or a wet sauna, doesn't matter. Or I think it doesn't matter a whole lot. It's the heat, the infrared energy that is being offered to our body, especially we take off our clothes. So the infrared is penetrating some wavelengths deeply, other wavelengths less deeply, but we're getting infrared, and the infrared builds EZ. So we walk in, we feel tired, depressed, pained, and whatever, and we sit there for 20 minutes and come out, take a shower, and we feel like a newborn again. And I think it's because the infrared light builds EZ throughout our body. So anyway, it has been my experience. And finally, grounding is, or so-called earthing, connecting yourself electrically to the ground. Now, why should that make us feel better. Apparently, first of all, it does. There have been lots of biophysical studies demonstrating that if we connect ourselves electrically to the earth, we feel better. And why is that? Again, lots of theories have come out, and I would argue that at least one component of that, maybe an important component, is the electrical charge. Let me explain. So most of us think that the earth is neutral in charge. And I got to tell you, I started my career studying electrical engineering. And no professor ever declared that the earth was anything other than neutral. And so you take a plug and plug it into the receptacle, and that third prong, the round one, is plugging into something neutral, and everything is properly grounded. And I got to tell you, it was a real shock to me, so to speak, when a Russian guy in my laboratory from Moscow, from Pushino, Science City, he spent 6 months there, and he was just about to leave that evening. He was headed for the airport, and we had a kind of final discussion in the lab, and he was talking about the Earth's electric field. And I said, Andre, you mean magnetic field, right? He said, no, I mean electric field. I said, hey, I studied electrical engineering, and I never heard of an electric field of the Earth. He said, well, there's something wrong with your educational system, because in Russia, every middle school student knows that there's an electric field on the Earth, and its value at the Earth's surface is about 100 volts per meter, the field, and it's caused by a capacitive kind of effect where the Earth is negative, and up somewhere, and maybe in the ionosphere, are positive charges. So you've got positive up there, and the Earth is negative. And between those like capacitor plates is an electric field that runs this way. And the Earth is negative, and everybody in Russia knows about this, and your educational system is defunct. So my head was spinning. I went home that evening and I was scratching my head. I had a little more hair then. And next morning I come into my office, and I'm greeted by one of my students who brings me the lectures of Richard Feynman. And all physicists know Richard Feynman. He's considered to be the Einstein of the second half of the 20th century. And he gave his lectures, and they're now codified in a series of books. And almost every graduate student in physics, at least in the US, reads those books because they're straightforward and logical and full of humor, relatively easy to read. And he's got, in volume 2, chapter 9, is all about the negative charge of the Earth and the evidence for such. And these lectures were given in the 1950s, so quite a while ago. And at that time, the evidence was maybe more popular than it is now. We've forgotten about it, but in that chapter, he outlines a long series of experiments that were done that demonstrates that we have negative charge of the Earth. Okay, so that's a prelude to item number 6. The Earth is negative. You connect your body to the negative Earth, and you can do that a number of ways. You can walk on the beach near the water, on the damp beach, barefoot, and you're connected nicely to the Earth, and you feel good after you've done that. You can immerse yourself in a mud bath, or you can do on the commercial route. There are devices now like a sheet of aluminum connected electrically to an iron rod, and you drive the iron rod into the Earth. And my son actually uses that. He sits in front of the computer screen all day and connects his feet to that.
Have you ever seen it through a live blood microscope, your blood cells before and after grounding?
Yes, I have. Yeah, and you find that before grounding, they may be clumped together. Mm-hmm. And after grounding, they're not clumped together anymore. Yes, it's powerful when you see that. I've also seen the cells after you've eaten a lot of pork chops
or pizza.
Oh, pizza too. Okay, pizza. I haven't seen that one. But,
Yeah, the cells get stuck together, start to coagulate. You
yeah,
lose the
Pizza?
negative charge. Pizza. Yep.
It's like
Don't
the
ruin
cheese and the
pizza for
pizza.
me.
It's cheese. It's the cheese. It creates an inflammation in the body or something. I'm not sure. I don't know the exact connection behind it.
Well, I don't think anybody knows for sure what's going on, but it is for sure that if the red cells are clumping together, you can get a clot. You don't want to get a clot. So anyway, so getting back to this, to the grounding. So we found in an experiment, we found that if you just take water, take a container of water and stick 2 electrodes in and pass current. So if you look at the negative electrode, what happens is an EZ forms around this negative electrode. And so it means that if you pass electrons into the water, that can build EZ. So now project that onto this. You take yourself and the negative charge in this case is coming from the earth, if you connect yourself from the earth. So the electrons are flowing from the earth into your body, just like the electrons are flowing from the wire into the water, and it builds EZ in the same way. So I think the reason why you feel good or better if you connect yourself is simply that, because you're building EZ. In this case, you're building EC inside your body, inside your cells, and so you feel better.
Wow.
So these are our 6 expedients that anybody can use to feel better. And some of them are pretty easy. I just want to, it's not on the list, but I just want to mention one more because I can't resist, and that is hyperbaric oxygen therapy. Not everybody has access to this.
Well, you mentioned pressure. You mentioned pressure originally, and that's what you're discussing now, right?
Yeah, you guys are right on the ball, I got to tell you. Yes, so we did experiments. So hyperbaric oxygen, what is it? It's high pressure and high oxygen. And we did experiments published to find out what does high pressure do, which I already discussed. It builds EZ water. And what does high oxygen do? Well, we studied that too. And it also builds EZ water. And one reason it builds EZ water is that EZ water contains more, based on the chemical formula, it has more oxygen per hydrogen than ordinary water. And so you add oxygen and EZ builds, and we published that. So in hyperbaric oxygen, the reason why it's so effective for curing so many issues, so many syndromes is, I think, is that it builds EZ water, and it builds it because of high pressure and high oxygen. So, these things are not easily accessible to everybody, but they're coming increasingly accessible because they're proving to be so good for our health. But anyway, these are the simpler expedients, and based on our evidence, I would suggest that these are expedients that can be used and yield really positive results. This one especially, the green juicing. If you're familiar with the Mercola website, Joseph Mercola, who's just been deplatformed because of his views on COVID. That's another issue, but he's been talking about green juicing as being perhaps the simplest and best expedient for achieving good health. And I've been in contact with various people who are practitioners who advise for their clients to do this green juicing, and the reports are extremely positive about the effect. So it's
CPAP machines too. You know what a CPAP machine is?
I do. Yeah.
That does positive pressure, right? When you're sleeping for COPD patients, would that create an easy field as well?
I don't know, but that makes a lot of sense to me. Yeah, I know about the machines, but I don't know so much about how they work. But you might be onto something important. That's about the 20th important comment that you've made, roughly, or maybe 25. I don't know.
I'm saving one for the end after I say goodbye to everyone, because I do not want to say it, because this interview is so freaking amazing.
Oh, well, thank you. You're kind okay. We're almost there. Okay, so yeah. So everybody's interested in practical applications. If maybe what I've told you is not practical enough, and there are some. So one of them is getting energy from water and sunlight, and you've seen this enough times to understand what's going on. This is the result of sunlight, infrared energy, and it starts with water and builds to this. So given this kind of arrangement, you put electrodes in. You put one electrode, I guess I'll try this one. Oops, that didn't do it. You put one electrode in the negative and one electrode on the positive. And in theory, you ought to be able to light a light bulb from it. Well, we've done the experiment, and here.
Oh my God.
Well, so I'll show you. So here you've got, I think, about a dozen cells, and in each cell is a piece of naphion and two electrodes, one in the negative zone, or where we expect the negative zone to be, one in the positive, and we could connect them either in series or in parallel. And this is a switch, and this is a magnifying lens, and behind it is an LED. Okay, so what we do is we turn the switch, and voila!
Oh
lights.
my God!
Yeah, so this proves that you can indeed get electrical energy from water and light, basically, two renewable resources. Well, I appreciate your enthusiastic reaction, but let me tell you, it's not as simple as all that, because this is a laboratory observation. You try to bring the laboratory observation into something practical, and you have to cross the so-called valley of death in between the laboratory observation and the practical application. And that valley is very deep, and a lot of inventions, discoveries, whatever from the laboratory wind up at the bottom of that valley because they can't cross over.
Have you ever heard of Victor Schoberger?
Yes, of course.
He has this incredibly interesting experiment where he drips of water, and it creates this electrical field, or I don't know what it is. I got to send it to you. I will send you this incredible experiment. That's very interesting, because he's talking about creating electricity through dripping water through this field, and he proves it. And it's been years since I've seen the video, but I'm going to find it. I'm going to send it to you. I think you're going to love it.
Oh, thank you. I would definitely appreciate this. I mean, yeah, all of this has great potential, but it requires investment, and investment in the fundamental science, and investment in translating that fundamental science, once it's all been really worked out in detail, into practicality. And
if Obama would have gave you that $500 million grant he gave to that solar company like 10 years ago, we would have probably been able to do something with that.
Well, maybe not. So I got to tell you that Cellular, the guy who ran Cellular with that big investment, Cellular went belly up, as you know, because the Chinese infringed on their patent. And we formed a little startup company, and the guy who was head of Cellular was our CEO. In that startup company. And we went actually in a different direction. We didn't go, but some issues occurred with the company, and it's not appropriate to discuss here. But at any rate, we're definitely interested, and we know about Cellular, and we could certainly use that $500 million would come in handy. I mean, this is the kinds of things that I'm showing you in this slide and the next slide. They're so potentially really important, and they can solve so many of the problems of society. And we're looking for people who have done well and want to give back, and would be willing to fund first the fundamental science that needs for the development of this idea, and then ultimately the implementation of it. The potential is enormous, as you know. Okay, so this is the electricity.
They said they are natural terpenes, right?
Yeah, they said they're botanical food grade terpenes.
Okay, so it sounds like they're potentially synthetic terpenes.
They don't use synthetic. They don't say synthetic, but that's what my feeling was as well.